Okay, so now let's go after A. Okay, we have two hydrogens, one attached to oxygen and the second one attached to carbon. Remember, the carbons, any carbon that you pick here, because it has double bond, it will have sp2 hybridization, while oxygen, it has two lone pairs and two sigma. So hybridization of carbon is going to be sp3. Okay, let's remember that. Carbon, any carbon that we pick here is sp2 hybridization. Okay, those are carbon, and any carbon, it has one hydrogen attached to it. Okay. And carbon comes with sp2 hybridization, while oxygen is sp3. Okay, I want to go after the hydrogen that's attached to oxygen. Oxygen, it has sp2 hybridization, and sp3 hybridization, and it has two lone pair. Okay, now how about the ring? How do we get those pi bonds? How do we get them? We have, clearly we have sigma between two carbons, but then we have, 3 pi bonds also. Okay, now this is the correct presentation of the ring. You have a ring, your ring completely flat. This is our ring. Okay, this is our ring. Ring is completely flat. Okay, let's make it that way. Okay, so the ring is flat, and then I see a bunch of orbitals. They are up and down. Okay, up and down the plane. And where is oxygen? Oxygen is completely perpendicular to the pi, or the green atom. Assume this is oxygen. The blue one is or purple oxygen, and the green are the pi bonds. Okay, now can I get the pi bond, or how do I get a pi bond? Let's attach. Okay, let's assume this is a plus, that one plus, 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 and the bottom there will be negative, 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 negative. You attach two positive. Okay, if you attach them, they will give you a pi bond. Okay, so these two are going to give you a pi bond. Okay, or I can start from here. I'm going to say those two, they will give me a pi bond, one pi bond. Okay, here I get the second pi bond. And then there I get the third pi bond. So I managed to get 3 pi bonds there. Okay, now let's show hybridization of oxygen. Oxygen, it right now attached to two atoms, carbon and oxygen, and they are inside the plane. Okay, which plane? Which plane? Okay, this is oxygen. Okay, this is oxygen attached to carbon. Where is hydrogen? Hydrogen is exactly inside the same plane that you have the ring there. So these two, okay, technically this bond and that bond, they are in the same plane. Okay, so again, this bond and that bond, they are in the same plane. Which plane? The ring plane. Okay, they're on the same plane. Okay, completely flat. Now let's show. Okay, let's show the hybridization. This is sp3. Okay, oxygen supposed to have two lone pair. Where are those two lone pair? One lone pair, it will be up. Okay, one lone pair is up, and it has 2 electrons. And that lone pair, it will be technically aligned with the p orbital. I'm going to show it here. Okay, and this is, let's give it yellow color. Okay, where is the second lone pair? The second lone pair, it will be back of the plane, and I'm going to show it by red color. And this one is going to be back of the plane. We don't see it. Okay, it's far from us. Okay, so this one is up, that one is back. Okay, now from now, try to remove hydrogen from oxygen and see what will happen. So I'm going to take this, and I will remove hydrogen from it. Okay, if I remove hydrogen from it, this is going to happen. Okay, so hydrogen is gone, but what will happen with those 2 electrons? Those 2 electrons, they will be given to oxygen. Okay, so oxygen is going to take those 2 electrons, and they will stay inside an sp3 orbital. Remember, any of this is sp3 orbital. So now we have, okay, 3 lone pairs and oxygen and a sigma bond, oxygen. It will be octet. I see 8 electrons around it. Okay, what do I have until now? Until now, I have this, okay, this technically structure. Okay, let me shrink the size here. I got a ring. Okay. I'm sorry. My bad. Okay, so I'm going to say I got the ring. Why do I keep saying ring? Yeah, it's a ring, but it's not like completely a circle. And then I have oxygen here. Okay, remember we have double bond there. Our oxygen, it has an sp orbital, sp3, and it has 2 lone pair there. There's one sp3 also here. We used to have hydrogen there, and there is one that is back. That's also sp3. So oxygen right now is -1. Can I share this lone pair, one of these lone pair, the one that is pointing up, the one that is pointing up? So I'm gonna highlight it. Can I share this lone pair with the ring? Yes, it's possible. Okay, yes, it's possible. Okay, and if this one is happen, if that one happened, you will see those 2 electrons will be given to the first orbital. You give it there. And if you do it, you will get such a structure. You will get oxygen attached to carbon through a double bond. Oxygen now is left with 2 lone pairs. Okay, that oxygen, that carbon, it will be attached to other carbons. Okay, clearly we have carbons there. Okay, and okay, for now, I'm going to just simply erase this one. Okay, that way. Okay, so now I have a double bond here, double bond there. But what will happen with this carbon? That carbon already has 1 hydrogen, but got a lone pair. And because it has a lone pair, it will be -1. Okay, -1. Now, can I draw another Lewis structure for it? Yes, you can draw another one. Okay, how about this? Can we go with this? So oxygen, okay, attached to carbon. Okay, so this time let's put double bond here. Okay, lone pair there, and double bond here. Okay, remember this one, it has hydrogen. So this carbon, it will be -1. Okay, and last one. Okay, I can have oxygen. Okay, 2 lone pairs attached to carbon. Okay, double bond here, double bond there, and lone pair here. And remember, hydrogen, that carbon, it has 1 hydrogen there. So now this one is -1. Okay, what was the starting point? The starting point was this. Oxygen, it has 3 lone pairs attached to a ring. In organic chemistry, whenever we have cyclic, or cyclic technique or closed loop, we call it ring. Okay. Okay. This one was our starting point. Oxygen used to be -1. Okay. I can have 4 resonance structures. I manage to take the negative charge that used to be an oxygen, put it on carbon, 1 second carbon, and next is going to be the 3rd carbon. So I got 4 resonance structures. If I take if I take hydrogen from oxygen, if I take hydrogen from oxygen, I will get 4 resonance structures. That's one. Okay. Now, what will happen if we take this hydrogen? If we take that one, in that case, what will happen? Okay. If we take that hydrogen, remember, hydrogen, I'm talking about it, that hydrogen is here. Okay. How did we make a bond between carbon and that hydrogen? Each of this carbon is sp2 hybrid. It has sp2 hybridization. It means any carbon, it has this technically geometry. It has an orbital that is using it for making bond with hydrogen, another one with neighbor carbon, and that's another neighbor carbon. So any carbon that we pick, it has this geometry for the hybrid orbitals. So I'm going to put this, I'm going to move it, and I will put this one somewhere there. Okay. And let me shrink the size a bit. Okay. And where is our hydrogen? Hydrogen is going to reach carbon through this side. That's going to be hydrogen. Okay. So now let's show. Greens are the pi bonds, and this is hydrogen. Okay, let's treat this one as hydrogen. Hydrogen, it has a 90-degree with the pi orbital. If I take this, if I take the hydrogen, okay, I will have electrons inside the sp2 orbital. They have nothing to do with the pi bond. Okay, remember the pi bonds, you get it after forming the hybridization. In fact, whenever we want to find the hybridization, we don't count the pi bonds. So what will happen if I remove, one hydrogen from this system? And I'm going to remove hydrogen from carbon, not oxygen. If I remove it, that hydrogen will be gone. Now what will happen? Here, inside that sp2 orbital, I'm going to have a lone pair. It means I'm going to get this. Okay. All these atoms, the carbon atoms, they are already acted. Okay. And they have zero formal charge except this one. This one is acted, but it has sp2 hybrid, it has -1 charge, -1 the charge. The negative charge, you cannot transfer it to the ring. Why? Because it's pointing out of the ring. It's pointing out of the ring. So you might say, what's going to be the problem? Like, why don't you just simply here add it to the double bond? No, because it has bond angle, the bond angle between the blue and the pi bond is 90 degrees. Okay, you cannot transfer electron of the py and then put them in px. That's not going to happen. So what will happen? I'm going to get only one resonance structure. Only one resonance structure. If I take hydrogen from a carbon of the ring, I get one resonance structure. If I take hydrogen from oxygen, okay, I get 4 resonance structure. And I'm going to go back. I get those 4 resonance structure. So which one is more acidic? The hydrogen that's attached to oxygen. Okay, so this hydrogen, okay, this hydrogen is more acidic. This one, like this example, is a bit complicated. Sometime around chapter 9 and 10, we're gonna hit the ring again, and you will see actually how we will treat these 2 hydrogens. For now, thank you very much, and I will see you soon.